are the quiz answers. First question. The car is making a 12-mile trip, travels the first 8 miles at 30 miles per hour, and the last 4 miles at 60 miles per hour. What's the car's average speed for the entire trip? So, two parts, A, B, and B, C. That's 8 miles, the other is 4 miles. Average speed is total distance by total time. And the total distance here is, of course, 12 miles. And now we have to find the total time. And because time is distance by speed, the time in the beginning, first part is 8 by 30, and second part is 4 by 60. And therefore you get the average speed is 36 miles per hour. In the second question, this is the graph, and you're asked to find the average velocity between 1 second and 4 seconds. If you look at it carefully, you can see that at 1 second the displacement is 0, and at 4 seconds the displacement is 2, which means that total displacement is 2 meters. So, average velocity is total displacement by total time, and since the total displacement is 2 meters and the time is 3 seconds from 1 to 4, so you get it as 2 by 3, which is 0.67 meter per second. In the third question, velocity of a particle is given as a function of time, and you're asked to find the average acceleration between 1 second and 2 seconds. And therefore you got to substitute the value of t in the equation, first as 1 second and then as 2 seconds. So once you get the velocities at 1 second and 2 seconds, the acceleration would be the difference divided by the time interval, which is 1 second. So when t is 1 second, we get 0.2 meter per second. And when t is 2 seconds, it's minus 14.3 meter per second. And therefore the acceleration is velocity at 2 seconds minus velocity at 1 divided by the time. Which is minus 14.5 meter per second squared, which is approximately minus 15 meter per second squared. In the fourth one, a car is traveling with a constant speed. Brakes are applied. The deceleration is given. The car comes to a stop in a certain distance. What was the original speed? So that's the initial speed we are trying to find. The final speed is 0 because it stops. Displacement is 30 meter. And acceleration is negative, because it's deceleration, it's negative 3.5. A simple use of this equation. This term is negative 210, so the answer is square root of 210, which is 14.5 meter per second. The fifth one, the car is traveling at 26 meter per second, brakes are applied, and the car comes to a stop in a distance of 120 meter. And how fast was the car moving when it was 60 meter past the point? So you have two cases here. In the first case, the initial speed is known, the final speed is 0. You have the distance is 120 meter, and you can find the acceleration. Using Vf squared is Vi squared plus 2a delta x. And once you get this acceleration, you can use it in the second part. Acceleration is 2.82, and now in the second part, just use the same equation, and we're trying to find the final velocity after 60 meters. So we have the initial velocity now, and we have the acceleration. Plug it in. That was a minus, and the answer is 18.4 meter per second. In the sixth one, it's a relay race, so runner A is behind and moving at 2.8 meter per second. He's 25 meter behind, and runner B starts from rest and accelerates. How fast is B traveling when A overtakes her? Okay, so assume that the overtaking takes place at that point and that B has traveled X meters, which means A has traveled 25 plus X. Therefore, for A, because the velocity is constant, the total displacement, x plus 25, is the product of velocity and time. But for B, we use x is equal to VIT plus 1/2 AT squared, and the initial velocity is 0, so that term is missing, but you have 1/2 times acceleration times t squared. So we have x as a function of time, substitute that into this. And you have a quadratic equation. I've multiplied throughout by 100 just to get rid of the 0.04, to make it 4. So rearrange that and solve the equation. Here it's a plus because it's minus b, remember, and it's already minus, so that's why it's plus. And when you solve it, let's go on to the other side. When you solve it, you get two answers. We'll take the smaller of the two because it's a relay race, and so 10.5 seconds. And once you have this time, we can find the final velocity. Because we know the acceleration. So 0.84 meter per second. In the seventh one, a boy throws a ball straight up, and times it she sees that the ball goes by the top of a flagpole after 0.5 seconds and then returns after 4.10 seconds. What is the speed of the ball at launch? So that is the flagpole. Oh, that's the flagpole there. And here it's 0.5 seconds and then goes up and then it returns after after 4.1 seconds. So what is the speed of the ball at this point? So these are two cases again. Now if you take this point and then the ball returning to that point, you know that delta x is 0. And we can use that to find the velocity here. Take that as the initial velocity. So that's the time there, or both the times shown. So I'm just considering BC. Delta y is 0, the displacement. Time is 3.6 because it's 4.1 minus 0.5. That's the time that has passed. A is negative because initially it's going up. And we're looking for the initial velocity at B. There is the equation into which you substitute and calculate V naught. Get that as 17.64 meter per second. That is the initial velocity at B. Now from there we can find the initial velocity at A, because when you take the part AB, the 17.64 becomes the final velocity here. Then we can find the initial velocity with which it was launched, because we know the time is 0.5 seconds. So that's the idea. So the final velocity is what we got just now. Initial at A is what we're trying to find. Speed it up a little bit. A is minus 9.8 meter per second squared, time is 0.5 seconds. Use this equation and calculate V naught. Turns out to be 22.6 meter per second. Find the height of a bridge above the water. A person drops a stone, measures the time it takes to hit the water. The bridge has a height of 41 meters. Now that is straightforward. Displacement is 41 and V naught is 0. That's why the first term has become 0. Okay. 2.9 seconds straight. An object is thrown upwards with a speed of 14 meters per second. How high above the projection point is it after 0.5 seconds? Again, straightforward. The initial velocity is given, 14 meters per second. Acceleration is negative 9.8. Time is 0.5 seconds. Okay. Here's the answer. 5.8 meter. Brings us to the last one. A direct question again. A stone is dropped from a bridge and it takes 2.3 seconds to hit the water. What's the height of the bridge? My, that's an easy question. These are just bonus questions, You get 26 meters, so here it is. I hope you understand all the answers, and thank you.